Hey everyone, welcome back to the channel. Today we are going to cover important decision that many developers and system architecture face when to migrate from a single node database to a distributed setup. Moving to a distributed database can be a big step, but knowing when the right time is can help you avoid scaling issues and keep your application running smoothly. So let's dive right in. First, what is a single node database? A single node databases are databases that run entirely on a single server. They handle all read and write operations from one central place, which works perfectly for small to medium workloads. For example, if you're building a small e-commerce website or a blog, a single node database like MySQL or PostgreSQL can handle all your needs without any issues. Let's talk about signs that you need to migrate. The first thing is increased latency. One of the first signs that it's time to migrate is when you start seeing increased latency. If your queries are taking longer to complete as your use base grows, it's a sign that your single node setup is struggling to keep up with the demand. Imagine running a real-time analytics platform as more users generate more data, the single node database can become overwhelmed, causing response time to increase, which leads to a poor user experience. Number two, storage limitation. Another clear indicator is running out of storage. Single node database have a limit on how much data they can store. Depending on the hardware, as your database grows, you may hit those limits. For instance, if you are storing millions of images or videos, your database may quickly run out of disk space, making it essential to move to a distributed system that can scale horizontally by adding more nodes. Number three, high read and write traffic. Diagram showing a high, sorry, if your application experience high read or write traffic, a single node database can become a bottleneck. This can lead to issues with downtime or throttling, especially during peak times. A good example is a social media app when users are posting, liking, and sharing content all at the same time. The single node database may not be able to handle all of these concurrent operations efficiently. Number two, fault tolerance requirement. Single node database have a single point of failure. If the server goes down, the entire database goes offline. As your application grows, you need high availability. Migrating to a distributed setup with redundancy becomes crucial for a banking application. As example, it's absolutely critical that the system remains available at all times. A distributed database ensures that even if one node fails, the rest of the system can continue operate. Okay, let's talk about the benefits of a distributed database. And the first thing is the horizontal scaling. Horizontal scaling allows you to add more nodes to the system to handle increased load. And instead of having to upgrade the hardware of a single server, this makes scaling much more flexible and cost effective. For example, Amazon DynamoDB is designed to scale horizontally by adding more nodes, making it perfect for applications that need to handle huge volume of transactions. Number two, improved fault tolerance. With distributed setup, data is often replicated across multiple nodes, ensuring that if one node fails, the data is still available from other nodes. This provides much higher fault tolerance compared to a single node setup. Think of it like if it like having multiple backups of your data. Even if one node experiences an issue, the rest of the nodes can continue serving user requests without any downtime. Number three, better performance under load. In distributed setup, the load is distributed across multiple nodes, allowing each node to handle a portion of the request. This significantly improves read and write performance, especially during peak times. For example, Cassandra is distributed NoSQL database that can handle large number of reads and writes operations by distributing them across multiple nodes, making it ideal for application with high throughput requirements. Okay, let's talk about the challenges of migrating to a distributed setup. The first thing it will be the increased complexity. Migrating to a distributed setup introduces a lot of complexity. You need to manage data consistency, network partitions, and node failures, which are not concerns in a single node setup. For instance, ensuring that data remains consistent across all nodes during updates can be challenging, especially in systems that require strong consistency. This is where techniques like quorum reads and writes become into play. The second thing will be data partitioning and sharding. To distribute data across nodes, you often need to implement data partitioning or sharding. Choosing the right partition strategy is crucial to avoid hotspots and ensure even distribution of data. For example, if you partition user data by geographic region, you may need to ensure that one region doesn't end up with significantly more data than the others, which could lead to performance bottlenecks. Okay, let's talk about best practices for migrating to a distributed setup. And the first thing, which will be the assess your application's needs. Before migrating, assess whether your application truly needs a distributed setup. Consider factors like traffic volume, data growth, and uptime requirements. If your single node setup is still meeting your needs, it might not be the right time yet. The second thing will be start with read replicas. A good first step before fully migrating to implement read replicas. This allows you to offload read operations to replicas while still maintaining a single node primary for writes. Next, plan for data partitioning. Plan your partitioning strategy carefully, whether you use range based or hash based or geo based partitioning. Ensure that the data is distributed evenly to avoid hotspot and performance issues. Okay, so in conclusion, to sum it up, migrating from a single node database to distributed setup is a big decision, but it can be the right move when you start experiencing latency issues, storage limitation, or need high availability. While distributed databases offer significant benefits like horizontal scalability and fault tolerance, they also come with added complexity that requires careful planning. If you found this video helpful, be sure to like it, subscribe, and hit the notification bell so you don't miss more content on database scaling and system design. And as always, drop your questions or experiences with migrating to distributed databases in the comment section below. Thanks for watching, and I will see you in the next video.